Hi everyone, in today's video we're going to be using Python to simulate the equations of motion for a simple pendulum. Then we're going to create and animate plots of theta and theta dot, and we're going to finish by making an animation of a simple pendulum using matplotlib. We're going to be using NumPy, SciPy, and matplotlib in today's example, so if you haven't, go to the websites and install those. Let's get started by defining g and L. So g is going to be the acceleration due to gravity, so that's 9.81 meters per second squared, and L is going to be the length of our pendulum. Let's just make that 1 meter for now. Then we'll define some initial conditions. So we'll have theta be 30 degrees, theta dot be 0. So that means the pendulum's not moving at time 0. Now we need to turn our differential equations into some Python code. So this function right here, it takes in a time t, and it takes in our state vector y, and we need to return y dot. So we're going to define y to be theta comma theta dot, and so dy is going to be this expression up here. So we're going to return theta dot, and then minus g sine theta over L. Okay, now let's solve the ODE, and then evaluate this 30 times a second. So we're going to say solve initial value problem. We'll pass in our function, our time range 0 to 5 seconds, our initial values, then the times that we want to evaluate this function at. So the output of the solver, pass those in. So this is going to be theta, theta dot, and t. And theta dot, they're both in radians and radians per second. So let's convert those to degrees. And that's really easy in NumPy. We just use the radians to degrees function. So one last thing that you might want to do is export this data to Excel. So we can use NumPy and export all this data to a CSV file and then open that up in Excel. So if we run that, we'll see it works successfully, and then we can even open up the CSV file. So here we see the first column is going to be theta in degrees, and the second column is going to be theta dot in degrees per second. Now we're going to use matplotlib to plot theta and theta dot versus time. So we're going to say plot t, and then theta in degrees, so theta in degrees, make that red, make the line width 2, and then let's label this, and I'm going to use LaTeX to label that. Let's also do the same thing for theta dot. So theta dot, let's make theta dot going to be blue, and then we're going to call this dot theta. So if we run this right now, we get this plot. But let's clean this up a little bit. So let's add a title right now. So we'll say, let's put the simple pendulum. We'll add a legend. Then we'll label the X and the Y axes. We'll add a grid, then show that to the screen. So run that again. And now we get this nice looking plot. Now that we've seen how to make a basic plot using matplotlib, let's go ahead and animate one. So we're going to start off by creating a figure and some axes. Then we're going to create our red and our blue curves. So we'll call this theta and theta dot. Then let's clean up our plot. So we're going to give it a title, X limit, Y limit, an X label, Y label, a legend, and a grid. Now this is where things start to get different. So we have this animate function now. So animate takes in a frame number I. So I is going to go from 0 to 150. And for every frame, we're going to redraw the theta curve and the theta dot curve, going from 0 all the way up to the ith index. So the I+1 is there because of the way array slicing works in Python. So if I was 50, this would give us frames 0 through 50. The last thing we're going to do is save the video. So this is pretty easy. We use this functAnimation function. We pass in a figure to update an animation function, and then tell it how many frames to do. Then we use this ffmpeg writer and tell it to do 30 FPS, and then we save the animation to an MP4 file. So if I run that, this normally takes a little over 8 seconds to run, and we'll see we get a nice static output in the Jupyter notebook. So here we go. So we have this nice image, and if I go and look at the MP4 file, we see we have this nice 5-second animation of theta and theta dot. Another useful plot is called the phase diagram, and that's where we plot one state variable on the x-axis and the other on the y-axis. Let's do that. So let's put theta in degrees on the x-axis and theta dot in degrees on the y-axis and make that a blue curve. So let's run that and we get this nice ellipse. So this is saying that when at t equals 0, we're going to be here. Then we're going to move around this curve as time progresses. And you notice that there's no friction in the system, so it makes sense that the pendulum is always going in this loop. And it's never going to actually stop moving. It's just going to always move in this loop. So we can clean up this plot by just adding a title, an X label, Y label, and a grid. So let's do that. And you see we get this nice figure where we move around. So it's not very obvious exactly how we move or how fast we're moving. So next we're going to animate this. Now let's animate the phase diagram. So we're going to start by creating a figure and some axes. Then we'll create our phase curve as well as a dot that's going to ride around on the front of the phase curve. Let's clean up our graph by adding a title, some X limit, Y limit, labels, and a grid. Now our animate function is going to be a little bit interesting this time. So we're going to be redrawing the phase curve like we did last time, but we're also going to be moving around this phase dot. So this is going to be at the very front edge of the phase curve. Now let's save our video at 30 frames a second again and run this. This should take about the same time as the last one did. So here we go, here's a static image, and then if we go and we look at the phase diagram, the MP4 file that we made, we see that we start there on the right, and then we move around. So I'll run that again. So we see how that red dot really traces out the movement of the pendulum and gives us a nice indication of how the phase diagram changes with time. Now's the moment we've all been waiting for. Let's animate the pendulum. So first, let's make this helper function. This will take in a value of theta and then return the x and y coordinate of the mass. Now let's create a figure, and the only thing to note here is that we're going to be using an equal aspect ratio for our axes. This is going to make sure that there's no skew in the final video file. Now let's start drawing the pendulum. So we're going to start by drawing a line from x0 and y0. So x0, y0, this is the coordinate of the pendulum at time 0, where theta 0 equals 30 degrees. We're also going to draw a circle for the mass. So let me get that for you. So this circle right here is going to be red. It's going to be drawn on top of everything, have a radius of 0.05, and be positioned at our x0, y0 coordinate. Now, we've seen this before, let's make an animation function. So for every frame I, we're going to find the new xy position of the mass, and we're going to redraw the line and redraw the circle. Finally, we're going to save our video, and let's make this into an MP4 file. So we'll run that, give it a few seconds. Here's a static image, and if we go look at the MP4 file, we see that we get this nice animation of the pendulum swinging back and forth. Okay, just for fun, let's do one more animation. Let's animate everything together at once. So I'm just going to copy in a lot of code real quick. So we're going to add in the time domain code, then let's add in the phase diagram code. Next we'll add in the pendulum code. We'll do a big update function. This is identical to what we did before. So here's our update. Then we'll save the video. So as this runs, let's talk about it. So the only new thing now is this grid spec. So what we want is to have a grid of graphs. So we're going to have the time domain in the top left. We'll have the phase space, or the phase diagram, in the bottom left. And then the whole right side, we want that to all be the pendulum animating. So what we're going to do is make a 2x2 grid where the left ones are going to be 1 by 1 and the right ones are going to be basically 2 by 1. Then we'll see this in the final product that will have this nice 1 by 1, a 1 by 1, and then this will end up being a 2 by 1 and a 2 by 1 stacked on top of each other, so that gives us a 2 by 2. If we run this animation, we'll see we get all the different things animating at once. It's very nice. Matplotlib is very customizable, so if you don't like the colors shown in this video, no problem, you can make your own color scheme. For example, let's make a dark mode. So we can just paste all these guys in here, run this code, and then now every time we run one of these, it's going to change all the colors. So here's a dark mode for the time domain plot. We can make a dark mode for the phase diagram, and even the video files we can do that with. So we can go over and we can look at the time domain plot now, animate that, and look at that. We have a beautiful dark mode for our graph now. As always, if you found this video helpful, please leave a comment, like, and subscribe. Thank you!